Hi everyone. So today we are going to solve this question, that is fruits into baskets, and we are doing variable size sliding window. So let's go to the problem, and this is the problem. You can read this. I'm going to explain this problem to you. So let's go it, and let's take one example, and I'm going to take this the third example. Okay, so let me write it, then I will explain to you. 1, 2, 3, 2, 2. Okay, so this is the array we have given, and the array represents these all are the trees 0, 1, 2, 3, and 4. This is the indices of these array. Okay, so every index is a tree. So let me make a tree. So this is tree, this is another tree, and all of the elements are there. This represents the tree, but tree has a different types of fruit. Like this tree that is present at the 0th index, it has a type of 1. Another tree, the present at index 1, let me do it with this tree, this is the tree has a fruits that has a type 2. This is the tree has a fruit of type 3, and this is the tree has a fruits of type 2, and you can say this tree and this tree are the same because they both have produce they both have fruits of same type, that is 2. So trees these two trees are the same, and again this has also fruits of type 2. So as you can see, this and this, the three or all of trees are the same type of tree, which producing the same fruits, same types of fruits. Okay, now what we have to do is, like, we have two baskets over there. This is the basket one, and this is the basket two we have. Okay, now in a one basket you can put one type of fruits. Okay, you can't put, like, you can put two uh, fruits of type 2 to, sorry, let me take another color so that you can understand. Okay, so this is the type 2 to you can put all the fruits of type 2. You can't do like, I'm going to take another type of fruits 3 and I'm going to put inside a basket 1. You can't do it. At a one time you can put same types of fruits in one basket. You can't do you can't put different types of fruits into a same basket. Okay, so we have two basket, and the rule goes for both the basket are same. Rule for both the baskets are same. Okay, now we have to find the maximum contiguous subarray, uh, number of fruits we can put. Like in this case, as you can find, the answer is like that. Okay, let me do this. Okay, in this case the answer is this thing. Like, you can take 2 and put in basket 1. You can take 3, you put basket 2, and remaining two twos put inside a basket 1. So 2 and 2. As you can see, both, how many fruits we have? 1, 2, 3. 3 fruits we have. So for this, answer is going to be 3. Okay, not 3, sorry, it's going to be 4. But how? Okay, sorry, 3 plus 1, it's going to be 4. Okay, really sorry, it's 4. This is 4. Okay, Answer is 4. In basket 1, there are 3 fruits whose type is 2, and in basket 2, there is only one fruit whose type is 3. So answer is going to be 4. And remember, this is a contiguous elements. So whenever you encounter like a 4 is the another type, let's say there is only there is also a 4 uh, tree. Let's represent this is a tree and it has a 4 uh, types of fruit is 4. So if you try to put, there is no way to put inside basket 1 and basket 2 because both are filled with different types of fruits. So we have to empty one of them basket. We have to like delete all the fruits from the basket 1 and basket 1 becomes empty. Now you can put the another types of fruit like in this case this is 4, so you just put this inside this, or you can do like remove this, remove all the fruits from the basket 2 and this becomes empty. So now you can put another type of uh, fruits inside basket 2, but you have to maintain the consecutive elements, like you have to pick the sub arrays. Okay, so how we are going to approach this? Let's see. The first approach is very simple and it's a brute force approach. Let me erase this all. What we will do, we will generate all possible subarrays. Okay, let's say this is the starting element of a subarray. So this all the subarrays is like this. Generate all the subarrays using two loops we can generate and find out the two elements. Like let's say this is the subarray we have generated for now. Okay, this is the subarray we have generated. Okay, now you have to take a map or data structure, put all the elements of for this subarray. This is the subarray we are taking. For example, there are a lot of subarrays we can generate, but for now we are taking this subarray and we will see how we will figure out is this our possible answer or not. We have to maximize the length, but first before maximizing the result we have to check is this the sub array can become our answer. For that we will take a map data structure map. In this we will take the frequency of elements. Okay, so what is the frequency? Let's say 1 has a frequency of 1, 2 occurs in this subarray 2 times, and 3 occurs in this subarray 2 times, sorry 1 times. So as you can see, there are three elements present inside this. So this is not our possible answer. Or you can use a set. What set will do? Set will store the unique elements. Unique. Okay, specifically use unordered set. Okay, there are two types of set, unordered set or simple set. Set, if you use set, then it will take log n time complexity for insertion and deletion. But if you use unordered set, then it average time complexity for insertion and deletion will be constant. Same for map as well. If you use map, then the time complexity would be insertion and deletion would be log n. But if you use unordered map, then the average time complexity for insertion and deletion would be big O of 1. That is constant. Okay, so use unordered. Ordered, if you use ordered, that means simple set or map, then it will one more feature is included, like all the data are stored in a sorted fashion. So this is and we don't want a shorted fashion right now in this problem. So this is set, and what we will do, like, start from the very first element and put the elements inside a set. Okay, then 2 comes, put that into inside the set, 3 comes, put, and 2 comes. And if you take the length of this set, you'll get a 3. So we can't store 2 again. I'm really sorry for this, because we have to, in set only unique elements are stored. So this is the unique element we have. Okay, and if you take the size of the set, you'll get a 3, but we want 2 unique elements. So this is not the feasible or a possible solution. Okay, is this clear? Okay, I hope this is clear. Okay, so we will do this for all the subarrays we will generate. Okay, let me write the code quickly. So we will going to use two loops. So it will be for int I equal to 0, I is less than n, I plus plus, and then for. So we are going to initialize something over here. So it would be set. We are going to use a set, unordered set in this. You can use unordered map as well. So that's not the concept. Like, you have to understand the logic. Okay, how we will figure out uh, this is not the feasible solution. Okay, after saying this is a feasible solution, then what we have to do? Then we have to maximize with our answer. Okay, so uh, unordered set integer. Okay, let's call it st, and we will start a loop int I j equal to I from j is less than n and j plus plus. Okay, so we have started, and st dot push, not push, we have to use insert in a set. This is going to be how we will insert the data. So it would be insert, what I'm going to insert, it will be the element. So it would be nums of j. Okay, so let's suppose there is a data 1, 2, and 3, 1 and 1. So these are the array. Let's say, suppose this is the array we have. Now we are starting from here, and we will put all the elements. So this can become my subarray, first subarray. So we will check if my st dot size. So after doing this, this will become my subarray. Okay, this is now become subarray. So I have to maximize our answer. Before that, we have to check if my st dot size is greater than or equal to 3, then we have to break this loop. Break. So if you find, like, this is an starting element, and you are generating the subarray, all the subarray starting from this element, then this is one subarray and this is another, then go like this. And whenever you find, like, in this case, this is the subarray 1, 2 and 3, you find that there is this has a size of 3. So you cannot proceed further. Like, if you proceed further, then you'll get the size of the set is always greater than 3. So we always want the size is less than or equal to 2. That can become our answer, that can be our possible answer. So for that, we have to maximize in this case. Okay, so we have to initialize a variable answer. Initially uh, put the value 0. After doing that, we have to maximize our answer. So it would be answer and I, sorry, j minus I plus 1, length of the subarray. How would we get the length? So let's say uh, this is the starting element 1, 2, 3, 1, 1. Okay, so let's say this is the starting element I and my j is also pointing to here. So this can be one subarray. So how would we get a length? So we will do j minus I plus 1, and that would be, let's say indexing would be 0, 1, 2, 3, and 4. Indexing 1, 1 minus 1 plus 1, it would be 1. So if you increase the j goes here, and let me erase this j. Okay, now my j is pointing to here and my starting pointer is here. So how would I get a length? I'm talking only about the length. Don't worry for the set and whatever. I am talking to how we will calculate the length. So my j is pointing to this and my I is pointing to this. This is my starting element. So I have to subtract j minus I plus 1. So what is j? J has an index 2 and I has an index 1. 2 minus 1 plus 1. 1 1 cancel. So the length is 2. As you can see, this is the subarray whose length is 2. So this is the way to calculate the length of the subarray. Okay, I hope this makes sense. Okay, after the loops end, both the loops end. Okay, so I'm going to return answer. Okay, so this is the first way of doing this. This is first way. And if we talk about the time complexity would be big O of n square, because two loops we are using. Okay, this takes big O of n and inner loop will take big O of n. So it become big O of n square. And the space complexity, because we are using set, so it would be n, because in a worst case, let's say 1, 2, 3, 4, 5, 6, let's say worst case, not this. So worst case would be 1, 1, 1, 1, 1. So this is an array. It has a like, let's say it has a length size equal to n, and as you can see there is only one type of fruits present, so we can put all these fruits in one basket, or you can put all these fruits in a set. So you have to go through all the elements and put into the set. So it will take big O of n, like uh, not big O of n, sorry, it's my fault, because set is, it will take big O of 2, I think. Inserting will take big O of 1, so I don't think this will take time complexity. Like say, if there are 1 1 1 present, one type of fruits are present, so inserting would be big O of n. So the time complexity would be big O of n. Okay, okay. So let's move to the optimization. Can we optimize this? Yes, we can optimize in terms of time complexity. Like we can reduce this time complexity to big O of n. So how we are going to do that? Using variable sliding window. So let's say, let me write it the array first, then we will see 1 2 3. Okay, 1 2 3, and I think 2 2. Okay, let me do indexing as well, 0 1 2 3 and 4. Okay, so this is the tree. All these are trees. Okay, Now we have to find the maximum length so that we can put all the fruits in two baskets, basket 1 and basket 2. Okay, remember I told you, like whenever you find a solution that going to solve using variable size sliding window, what we always do, we initialize a small window and then we will expand the window according to question and will shrink the window according to question. It depends on the conditions. In what in a various problems you can, like, there are different types of condition, you can expand or shrink. Remember, we will start from very small window. So let's say this is the window we have. uh, Let me use the color, this yellow color. Okay, so this is my initial window. Okay, the left, let's say L, and the right, L is the left pointer and R is the right pointer. Okay, the left and right pointing to the same index. That means this is very small window you have, like one element inside this. So L and R represent whatever the elements in between. These are the current sub array you have. Sub array you have, or you can say window. Okay, so we can either expand the window or shrink the window according to question. So let me remove this. Okay, so this is the right pointer we have, and I'm going to use a date map as well. So let's do a map over here. So this is a map. Okay, what we will do, the very first element we are going to put over here, and its frequency for now, this is 0, sorry, 1. Okay, after doing this, so this can be our answer because map has a size. For this map has a size, if you do mp dot size, you'll get equal to 1. So this can be your answer because it's not exceeding to 3. So this can be your answer. So we have to maximize. So let's store the answer. Answer initially 0, but this can be your answer. So we will increase or update the answer variable with 1. Okay, so this is possible. So we have to expand the window, because is this possible? If whenever the current window is a possible answer, then we have to maximize our answer, and then we have to expand the window. Okay, after expanding the window, now my window looks like this. Let me take a stock. Okay. Now my window is this. This is my window and my right pointer is pointing to this. Okay, now I have added this element, so we have to put inside a map. So it would be 2 has a frequency 1. Okay, again, if you take mp dot size, if you take the size of map, you'll get 2. This is again a possible solution because we have two baskets. We can put one over here, two over here. Okay, so we have to update the answer, maximize the answer. So now it would be 2. Okay, now if this is the possible answer, this window is possible answer, so we have to expand the window again. We have to maximize it, so we have to expand. So erase this, and now my window looks like this. Okay, so my right pointer is pointing to this, and this is new element I have added. So we have to put this into map. So it would be 3 of frequency 1. Oh, 1 second. Okay, this is the window we have. And if you find the mp dot size of this, you'll get a 3. But as you can see, 3, we cannot put 3 types of fruits in 2 baskets. This is violating the conditions that we have. One basket, one type of fruits we can put. Another basket, we can put another types of fruit. So we can put at the time only 2 types of fruit into 2 baskets. So there are 3 types of fruit. We can't uh, put 3 types of fruit in 2 baskets. Okay, so we have to shrink. This is the condition we are going to shrink the window. Shrink the window. Shrinking means increase the left pointer, delete from the left side. So now my left pointer is pointing to this. This is my left pointer is pointing to this. So I'm going to increase my left pointer to here, and my window will become like this. Okay, and we have removed this, so we have to remove from the map as well. Okay, so we are going to remove this. So if we decrease the frequency, it will become 0, but we cannot we have to remove this from the map. If you try to now mp dot size, you again get a 3, but inside the current window we have 2 types of fruits, not the 3 types of fruit. So to solve this, we have to remove this, and for that we have to use mp.erase, and we have to provide the key of this. So it will be 1. So after doing this, then we will only we will get a size of map is 2. Otherwise, it will not. Decreasing doesn't mean removing the elements. It will decrease the frequency. Okay, if you want to remove the key, then we have to use mp.erase. So we will check if my elements frequency becomes 0, then we will remove. Okay, so this is the edge case you have to remember, because most of the time students forget this thing. Okay, now if you try to access the map.size, you will get 2. And this can be a possible answer. This window or sub array can be our possible answer. So we have to first of all maximize it. So if you do maximize, this is already 2 and the current size is also 2. So we cannot uh, update, or you can say it won't change. Okay, so if this is possible answer, so we have to expand again. So let's expand this. My right pointer is now pointing to this index, that is 3. Okay, so my current window is this. Okay, so if you have included this element, so you have to increase its frequency. So previously it was 1, now it will become 2. So this is 2, and if you take this size mp.size, you'll get 2, because there are 2 elements present. Okay, now you have to take the length of the current window, and as you can see it has a length 3, so we have to update this with 3. Okay, now this is the possible answer, so we have to again expand the window. So my right pointer is pointing to index 4. Okay, so my current window is this. and we have added this element, so we have to increase the frequency of this, so it would be 3. 2 has a frequency 3, and if you find the size of map, you will get 2. And again, this is a possible subarray, so we have to take the length. What is the length of this? It would be 4, so we have to update our answer with 4. So this is the way we are going to solve this problem. Always remember, whenever you are solving, whenever you find out the problem is variable size sliding window, then what you have to do, you have to just initialize a small window and think about on what condition it's going to expand, on what condition it's going to shrink, and then according to problem maximize it or minimize it. Okay, so this is the way we are going to solve. So let me write the pseudo code or directly write jump to the coding. Okay, so we are going to jump directly into the code part. So okay, so it would be let's create a variable called n. It's going to store size of the array. Okay, now we are going to create a small window, and first of all we are going to create a unordered map. Third map or int mp, let's call it mp. Okay, so small window is like L is pointing to index 0 and R is pointing to index 0. So while my R is less than n, that means my right pointer is first reaches the end of the array first. My left pointer doesn't exceed right right pointer. Okay, so we have to check for the R. Okay, then I'm going to increase the frequency of this, the R pointer is pointing to, so it would be fruits of R plus plus. That is the way of increasing the frequency. If this element is not present, let's say one second, let's say my map is this: 2 has a frequency 2 and 3 has a frequency 1. One new elements come into elements like 2, 2 and 3 and 4 is come. This is my array, and if 4 is come, this is my right pointer is pointing to, and if 4 is come, and as you can see there is no 4 present inside a map. So by doing this thing, that means first of all 4 has a frequency 0, this will occur. Then we are doing plus plus incrementing, so that means this is going to increment with 1. Okay, so this instruction is for that. Okay, after doing that, if while my mp dot size is greater than 2, that means it has a size 3, 4, 5, whatever, it is greater than 2, then this is not the possible solution. So what we have to do, we have to shrink the window. How we are going to shrink? My left pointer is going to increase, and I have to remove all the elements from the left. So it would be mp of fruits of left, decrease the frequency of that element, and we also have to check if my mp of fruits of L, my right pointer, is becomes 0. If the frequency of that element becomes 0, then we have to remove the element as well from the map. So how we are going to do? Mp dot erase. What we have to erase? It would be fruits of L. the left pointer is pointing to, and that's it. This will erase the element, and we have to increase my left pointer, that is L plus plus. After this, if this is not the true, that means if my while loop, if my map size is less than or equal to 2, that means this window can be your possible answer. So we have to maximize our answer. So answer is going to be maximized with answer and the length of the current window. What is the length? It would be R minus L plus 1. This is the window, and we have to initialize our answer variable as well with 0. Okay, after doing this, if my this loop ends, my right pointer reaches the end, then we have to return our answer. Return answer. Okay, let's run this. And why it's taking so much time? Okay, time limit exceeded. So we have did some kind of error. While r is less than n and p of I. Okay, so we are not increasing the r right pointer. Okay, so let me run again, and as you can see, all the given test case is passed. So if I try to submit this, and if we discuss the time complexity, it's taking the big O of n, and you can analyze the time complexity as well. Okay, so it's taking big O of n, and the space complexity would be big O of n as well, because we are using map. So the time complexity would be big O of n, and the space complexity would be big O of n again. Okay, now can we optimize this? Yes, we can optimize this. Uh, we have two baskets, so basket 1 and basket 2. So we can take a two variable, and uh, we can solve this using two variables. So the we can reduce the space complexity to big O of 1, and the time complexity would remain big O of n as well. So we are doing this in the next video. So if you want to try with your own, you can try. It's very simple. Like whenever you encounter a third, let's say this is the type you have put, and whenever you encounter a third type of uh, fruits, then you have to remove the recent one, last used types fruits. So think about it. It would be very easy because you are going to take two variables, basket 1 and basket 2. Then we will able to solve it. Okay, so this will take one more video, so you have to wait for the next two, because I'll put this all three elements into hard category because it's a hard, uh, not that much hard, but if you try to solve it using the space complexity big O of 1, it eventually becomes a hard problem. How you are going to approach this, although I have serve you some idea to how we are going to approach. So see you in the next video. Thank you for watching.